name is Alex. I'm going to talk to you about cloud-native architecture. And for those of you who can read the subtitle, I figured you all probably woke up this morning saying, I'm gonna have to terraform my unikernels today. Today is the day, right? No? All right, okay, I'm gonna tell you more about that as well. So seriously, I know the title has architecture in its name, but we're gonna dive deep in this one. So it's gonna be fun, I hope. But before we dive in, a little bit about me. As you can see, this is a pretty dated picture. It's actually from 2004, when I came over to Gurgaon for the first time. And as you can see, I still had hair at the time. So much has changed. What hasn't really changed is my love for the food over here and the great friends I've made over time. As you can see, I'm also a big fan of beer, which is no surprise because I'm from Munich, Germany, the beer capital of this lovely world. And I was much delighted to see that our beer has made it to the Punjabi by nature. That's just fantastic. That's awesome. All right, that's interesting, I guess. A little more interesting to you might be what I've been doing at Sapient for the last couple of years. It's probably not that different to what you guys have been doing because you've been my teams. So a lot of content management work, portal implementations, bit of commerce here and there. And really, it hasn't been much about the cloud, I have to say. So when I got started with CMTOU, and they got us to choose topics, and I picked this one, the cloud. I thought, cloud? Well, that's for hosting, right? That's when I pull out my credit card, go to AWS and buy some servers and do some stuff there. Well, I'm in good company because that's how most of the CIOs of this world approached the cloud 7, 8 years ago when the first public cloud vendors came to life. It was all about take your existing applications, put it into some kind of virtual machine, and then lift it to the cloud, Jim, or Bob, or Scott. So for a long time, that's been the main driver for using the cloud, right? It's a hosting alternative. Who knows what's happening on that date? That's a surprise. Travis knows about it. All right, this is Black Friday. All right, so one of the busiest days on the web when it comes to traffic in general, e-commerce transactions. It's the day after Thanksgiving in the US and generally the start of the Christmas shopping spree over there. So that's when all the retailers rejoice and say, wow, we've got all this traffic coming in, awesome, this is better than the whole year went. For us as technologists, that's a pretty scary time, or at least it has been the last few years, before we figured out how to use the cloud to scale, right? So it's a much less scary date nowadays. I think we've got that under control by now. But if you think about what's going to happen in really just not even 5 years from now, right? These are figures from several analyst firms out there. I think we're going to look at something that I would classify as planet scale. So to start off, we're going to see a lot more people, especially from the emerging, developing nations and continents, to use smartphones to access the internet. So literally, a whole new set of people that aren't there on the internet today. Then another class of devices that's also just not there today, right? 50 billion IoT devices. You've heard that number a few times today already. So our applications that we build will want to interact with these devices, get data from them, and play data to those devices or reconfigure those products dynamically. And last but not least, once we get the whole planet, the whole population onto the internet, I mean, obviously that increases our chances to interact with many more friends, followers, and social networks will just explode even further. Now you take all of this combined, and that will make Black Friday look like really any other day. Yeah. Now that's all well and good for the cloud, right? So great hosting option, great for scale. It's going to help us. Let's look at a company that was born in the cloud, Airbnb. Now before coming here, I checked out what kind of options we have for Airbnb in Delhi, and it's quite interesting. It ranges from, I think, your house, right, to grand villas that you can rent. So it's an amazing platform for anybody who wants to travel the world. What's great about them is they don't own any of these properties, right? Their whole business is grounded in software. They are essentially a software-defined business. Think about that for a moment. A software-defined business. The growth rate with which they've conquered the market is astonishing. They started out as a 3-person team in Silicon Valley, and now their platform hosts more rooms than some of the largest hotel chains on the world combined. How did they do it? Again, their whole business is software. So they can move at a very fast pace, they can change their business around as they want, and they can grow and scale with the means of the cloud. And that's what makes them so powerful and a true challenger in that very industry right now. So the travel industry obviously isn't the only one that's being affected by this trend. You find examples in each single other industry out there. And another example of an industry that's very afraid right now of being disrupted is the finance sector. So this is Jamie Dimon, the CEO of one of the largest banks in the US, JP Chase, and he's afraid of tiny startups coming out of Silicon Valley. Why would a man like him be afraid of a tiny startup coming out of Silicon Valley, right? 3 guys in a garage, literally. Well, what he's really afraid of is the frequency and the speed of change that these software-defined businesses are operating at, right? Because they have figured out how to use today's technologies, today's cloud technologies, to their maximum level. And that's something that's very different to the operating model of the classic industries. Now, classic industries, we can beat them up, right? And say, haha, you're the old guys, you'll never make it, we are the digital natives, excellent. But even we, in this room, are in the same kind of position, right? So even though we think we are the digital natives, we also need to watch out that we really hold on to that train of software-defined businesses and make sure that we are as effective as these 3 guys in the garage or the Facebooks and Googles in the world, and really make use of cloud-native technologies like they do. Because what these companies have realized, these software-defined businesses, is that it requires a radical new way of constructing software in order to really leverage the cloud. And that's what this is about, right? My strong belief is that only technologists who fully embrace these new cloud-native architectures will be able to influence and work with these software-defined businesses of the future. One company that has done particularly well in this, you've heard them multiple times already today, is Amazon. So what's striking about this quote is 2 things. One, Jeff Bezos set up his company on this whole track in 2002. That's 13 years ago. That's light years, right? And the second thing that's striking about the quote, well, he put a bit of a push behind this as well, right? Anybody who doesn't follow this will get fired. So it's in my interest today that nobody in this room gets fired. And instead, we all thrive of this and really turn it into something positive for us as a company, but also for our clients, and we push them forward so that they are the winners in this disruptive world that we're living in at the moment. Now, to understand a little more about what we need to do as technologists to become cloud native, we obviously need to understand a little bit about what's going on in the data center. So I invite you onto a small journey into that data center. This is actually a picture from Sheldon's bedroom. No, it's not. So one of the things that is really changing in data centers at the moment is how you do virtualization, right? Virtualization has been around for years, and we're pretty good at it. So if you look at the left-hand side, that's no news. That's what we do day in, day out, right? So we take our application stacks, we put them into a virtual machine, we put a little guest operating system underneath it, then all of that gets nicely put onto a virtual machine hypervisor that runs on Metal. Brilliant, job done, right? So if you've ever used that outside of a data center and tried to use a virtual machine on your development laptop, what's the experience like? Starts up really fast, right? Matter of seconds, awesome. No, it doesn't. It doesn't. It's terrible. It sucks. It takes minutes to boot up. Nobody uses that after trying it out 5 times. So to the right, you see something that has sprung up only roughly 1.5, 2 years ago, and that's container technology. The basic principle behind that is you get rid of the virtual machine, you get rid of a guest operating system that you need to boot up first before anything happens, and instead you make use of core features of the operating system, especially in the Linux world. You make use of namespacing. So much like you do it in your programming languages with package names, you basically tell the operating system, okay, this is one application. It just gets that process, and it gets a bit of that I/O, and it gets that namespace. And next to that is the other application. It gets that namespace, gets that I/O. Nice way to shield it. The massive benefit is you don't have to boot up all the other stuff from the left-hand side. This stuff starts in seconds. And I'm not even talking about 10 seconds, but a few seconds. All right, so I mean, for developers, the first time you try this out, you can't believe it. This is awesome technology. All right, but it's, as so many times, it's not just tech for tech's sake. Right? What this enables us to do is not just the same stuff as over there. Right? We shouldn't just take the same old applications, put them in here, and be happy that we can now have more time drinking tea. No, that's not the point. What this enables us to do is to split up our existing applications into much smaller pieces. Think about processes, applications, not machines, right? And again, why is that useful? Why is that useful for us in the business? Well, because think about your major releases, right? Right now, that's a panic mode activity. Everybody goes, "Whoa, release, whoa, 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 whoa." Oh, that's gonna be my weekend gone. In this kind of model, you can only release the parts of your application that really change, right? That's a major benefit for us, better use of our weekend time, and for our businesses, our clients, because they can move much faster. Of course, the big company that made all of this popular, started in 2013, was Docker. Docker started as an open source project, and what they made differently is they really focused on the developer experience. Because what I was just showing you, the container concept, is actually more than 7 years old as well. Right? It started in the Sun Solaris world. The Linux guys, they knew how to do it for a long time. So why didn't it pick up earlier? Well, it's quite simple, because you had to be a guru in kernel patching and all of that stuff, which, frankly, I don't enjoy much. I don't know about you guys, but it's not what I like to do, right? So Docker made it very user-friendly to get into this technology. They were very good at marketing it to developers like us. And that has led to a unheard of growth rate. And this is not 18,00%, this is 18,000% growth in just the last 2 years. If you look across all their metrics, whether it's download rate of their software, whether it's contributors to the open source project, across all levels, right? Massive growth. Now, with all of that growth comes competition, and for a certain time during last year, 2014, there was actually some danger of this market being more fragmented because many more container formats were coming up, and people were saying, well, maybe Docker isn't the finest thing, maybe there's something else we could try out, right? Thankfully, though, just in June of this year, so really a couple of weeks back at the Docker conference, literally the whole industry came together, including all the competitors of Docker, and they agreed to something that's called the Open Container Format under the umbrella of the Open Container Initiative. I mean, this is an amazing selection of logos. If you look at it, this is not just a Unix play, right? You have Microsoft in there as a big supporter of the whole initiative. You have all the big enterprise IT guys from Oracle to IBM, HP, you name it. You also have more of the old school virtualization folks from VMware in here, right? Sorry to call them old school already. I mean, it's crazy at what speed we're moving. So really impressive combination and a great sign that this technology is now ready for enterprise adoption by our clients, right? It's getting very real. If you think back just a few slides on what I told you about cutting down your application to smaller pieces so that they can leverage these containers, that means we're not dealing with just 3 or 4 machines anymore. We're potentially dealing with hundreds of small containers now. And if it's your task to put together an infrastructure for that, you might be wondering, that's a bit complicated now, isn't it? How do I put hundreds of those little things onto machines, onto metal? Well, that's exactly what the term terraforming describes. So you're building land for those containers. And there are a couple of companies operating in this space that will help you to automate exactly that process. So of course you have the proprietary vendors like AWS with their CloudFormation service, but you also have new companies coming into this space like HashiCorp, who some of you might know for Vagrant. They have a new product that is actually called Terraform. And the exciting new functionality in that is that you can pull together aspects of your infrastructure from different public cloud vendors. So you can literally go in there and say, here's my config script. I want a load balancer from Google because I know these guys are really good at that. I want a bit of virtual machine from Amazon. Oh, and storage today is really cheap at Azure. I'll put all of that together. That is now possible, right? So really exciting. And of course, once you have your infrastructure and you have your containers on there, well, you want to react to traffic spikes, right? That's what all of this is about, scale and dynamic scaling. That's the orchestration piece. Again, multiple vendors on that scale. Probably the most popular here is Google with their Kubernetes project. And very similar to the Open Container Initiative you've just seen, there's yet another foundation that's come up. So I don't know what it is at the moment, but it seems to be foundation season out there in our industry. So just, I think 2 weeks ago, they founded a new cloud native foundation to which Google contributed all their source code. Again, almost all the same members that you've previously seen are part of that initiative as well. And they are now making sure that we can also manage our container fleets and really start them up and shut them down dynamically based on algorithms instead of having to sit there and watch machines and click buttons, all of that orchestrated automatically. Now, most of you know this as well as I do. Technology never stands still. And especially for the container concept, there's already research going on in some labs on how to make things even smaller, even faster. And that's unikernels, the stuff that you wanted to terraform this morning, remember? Right. So what is the concept behind a unikernel? Well, remember what containers are doing. They're getting rid of the guest operating system and the virtual machine layer. Unikernels take it one step further. They also get rid of most of your host operating system. So they take just the bits and pieces they need. So a network driver, bit of an I/O stack, right? But not all the rest. You don't need a text editor for everything, right? You don't need a shell for every container that you run. So it's a very small portion of your operating system, just enough to run on metal. And what's the result of that? And what is this weird web page we're looking at? Well, this is one of the famous demo sites for a working unikernel in production. If you go to the site, you've probably read it by now. What they do is for every single request that hits this URL, they spin up an instance of their unikernel. Inside of that unikernel, they start the application that renders this page. And if you go to the bottom, this is not just a static HTML page, there's dynamic stuff going on. Right? So they render that response dynamically, send it to you, then they shut down the instance, and it disappears from the cloud. All of that within 300 milliseconds. Now compare that to your VMware instance or your virtual box on your development laptop. Very different speed. Well, to summarize our little journey into the data center, containers, and now I'm talking about containers in real life here, are really something that will drive this industry forward because they are a new type of standard that we've been waiting for so long. I mean, if you compare it to the real life, these kinds of containers, they are also standardized, right? They fit into every crane, into every ship on this planet, and they are the big enabling factor of global commerce, of global trade, right? Without those standards, no global trade. And the same goes for containers and technology. Now that we have this new standard that the whole industry seems to be behind, we can finally come true on the promise of write once, run anywhere, right? How many times have we heard that? Can't count it anymore. It's finally coming true. All right, now, so back from the data center into this interesting place. That's Furtwangen im Schwarzwald. This is a place where people would say the cloud is das Cloud. Yes, my friends, this is Germany. This is actually the tiny town of my university that you see in the middle there, where I was studying computer science back in the days. And I chose this picture because my whole research period about the cloud at CMTOU got me to think about those days and how I first discovered this book here, Design Patterns by the Gang of Four. And I can see somebody going, oh, yes, we're going to go page by page now. I'm going to ask questions to you. Oh, no. Right, okay. So I figure you remember this stuff then. So that's the Gang of Four, named after the four authors. At the time, for me, that was quite a revelation, this book, because I had been coding before coming into university, right? But it was just random stuff I was producing, right? And there was no structure, no patterns, certainly. And that was really an eye-opener at the time. So nowadays, we have a new gang in town. It's 3 of them. And these are sort of independent guys, but they all describe this new cloud-native world that we're going into. And they're coming from different backgrounds. So to start from the left, we have the 12-factor app. This is a set of guidelines that the guys behind the Heroku platform as a service have put together. Heroku is maybe known to some of you who are into Ruby on Rails, because that's what made it famous. That platform has recently been bought by Salesforce, another big cloud company. So they describe a lot of their best practices here. Then you have the reactive manifesto, a little less known, and certainly a big hype at the moment is microservices. You can read a lot about that on Martin Fowler's site. And unfortunately, we don't have the time to go through all of these. So I try to distill it down a little bit and give you my perspective on what are the key elements of these new cloud-native patterns here. So in a nutshell, I believe we're talking about a new way of doing distributed application design. Right? Because when you have hundreds of these little things running around you and that makes up your application stack, you better know how to coordinate that. Right? Not just as a ops person or a DevOps guy, but as an application developer in the first place. So first of all, we're in the cloud, right? So forget about getting a bigger machine for your problem. Think about scaling out, not up. And that means the application that you built is something that you don't want to modify at runtime anymore. You don't want to inject configuration onto something that's running in hundreds of nodes around you, right? That has to happen at build time. So that's quite different to what we've just learned in DevOps a few years ago. So what we really want to do here is inject that straight away, and that leads us to immutable infrastructure ultimately. Sounds great. What is that? That means that once you've baked your container and your application together with your configuration, you should not touch it anymore, right? Otherwise, how are you going to let these Kubernetes and all of these lovely automation tools spin up new instances? You can't just run another release cycle and do config scripts and all of that. It has to be fixed, baked together. You just start it, you shut it down, you start another one, you start another 300 of those. It has to be immutable. And to cut your application down in the first place, we need to relearn a bit about domain-driven design, bounded context. It's not enough to just say, okay, I cut my application by business entities. That's a great start. But you also need to go down into your data layer and do the same over there. And why? Because these entities are really that, entities, right? You want everything coupled together in one instance so that you can independently deal with that. Last but not least, our applications have to learn to become stateless, right? So no more sticky sessions, session sharing, all of that. We need to outsource, literally, our session state into data services that are obviously stateful, but our core applications, our logic, has to become stateless. Otherwise, again, how do you dynamically scale up hundreds of those instances if you first have to share the state with all of them? It doesn't work anymore. So if we all get on board with this, then we too can become like Airbnb and move at their pace, right? And evolve our software at a very different frequency of release cycles than what we're typically used to right now. So if this is all a bit much for you, terraforming, distributed application design, welcome to my world. I also think this is hard to take in. It's a massive change, right? The good news is if you want to chime in and say, run it on the cloud for me, but I don't care how, well, then there's something for you. Platforms as a service, or the worst acronym in IT history, PaaS. So these kinds of platforms help you to get started with cloud-native development without having to do all of the fiddling and connection building yourself. So they give you three things. Of course, they give you a standardized way to deploy your applications. Then you get a set of cloud-native services. That means you get cloud-native databases, cloud-native messaging middleware, and you get all the tools you need to run an efficient DevOps process down here. So this is an architecture diagram from the guys at Cloud Foundry, which is basically the de facto standard for platforms as a service at the moment. And as you can see at the bottom, again, like with containers, this is very much a model that can run anywhere, from Microsoft into the private data centers with VMware and the public cloud vendors. So really interesting technology. And this is not just something that technologists love. Even our partners are getting on board with this now. So people like SAP Hybris are currently re-architecting their software stack to work in this kind of world. Cloud native, microservice-based, running on platform as a service. And this is what it looks like. So I want you to focus on the stuff in blue. So what Hybris is currently doing is exactly that domain-driven design and focusing on smaller services that can live on their own. So as you can see, they have cut down their application into small business services, but they've also done the same thing, as I said, on the data tier, right? So this is a pro tip. If you want to catch somebody on a microservice hype, so somebody that tells you, oh yeah, I'm doing microservices, I've got it figured out. Let them show you their architecture diagram. If they still have one massive data layer underneath, you can now call them out. Now, important thing for us, I guess, is this is our partners doing this stuff. So it's high time for us to get on board and understand how we can customize and extend this moving forward. Platforms as a service is not just something that happens with Cloud Foundry as a de facto standard. There's more competition and more movement in this space than I had thought of initially, to be honest. So this is the latest and craziest example I've heard of. Maybe some of you have as well. This is AWS Lambda, just launched into production a few weeks ago. It's a new offering from Amazon that's allowing you, much like Cloud Foundry, to just deploy your code into the cloud. But what they allow is you can actually just deploy single methods of Java code or Node.js code into the cloud. A single method. Why is that interesting? Well, because that's sort of their version of a unikernel, right? It's the smallest possible unit of code you can think of. You don't have to care about servers at all. Amazon will take care of scaling this, making it highly available, and in terms of charging for it, they will do that by the method call in 100 millisecond increments. So if anybody in this room still doesn't think that performance testing is important, you'll pay for it next time, literally. And this is a general trend that I'm seeing with most of the cloud vendors out there at the moment. So infrastructure as a service, we've got that covered. That's becoming a commodity game, right? And all the vendors are becoming really good at that. Where we're moving at is developer support, and you can see that with all the latest services that Amazon has launched. None of them really concern infrastructure in the cloud. It's all about the developers. It's all about us as architects to work in the cloud and work differently in the cloud. So, are we ready to fully embrace cloud-native architectures? This is the point where you respond with, yeah. Good, not bad for this time. Well, you should respond like that because, like Mr. Bezos has said, this has something to do with our jobs. It's quite groundbreaking, believe it or not. The good news is this is a massive job machine again, right? So these new skills that I talked about, if you can ramp up on those and really show that you have what it takes to work in a cloud-native environment, you will be in high demand. This is already kicking off, and again, this is not just infrastructure. This is how we build and architect applications. All right, so if I have your attention there, And of course, here are some tools to get started. There's a couple of really fresh books out on the market. If you want to follow the people that I've learned all of this stuff from, I have a list on Twitter that you can subscribe to. But most importantly, go out and try it out and start coding this stuff yourself, right? There's many of these platform as a service vendors that offer you free tiers of their software, and you can get started for nothing. And even some of the popular frameworks support this approach more and more, so it gets easier than ever. Now, I want to leave you with a small outlook into the future of where this might be going. So right now, we've seen the starting points of all these clouds coming together under standards, right? This is quite an interesting time, and it feels, not only for this gentleman, like the beginning of the internet. This is actually Vint Cerf. If you know his history, he's the guy who brought us TCP/IP, right? The underlying protocol that enabled the internet, the servers on the internet, to actually talk to one another. So we're really at that kind of point in history again, right? Where everything that we've done so far is being changed by technology. And I believe we will sooner or later move into a world where the clouds of today that are still very much centered around massive data centers will move into a much more distributed world where all of the devices, all of the technology around us, from mobile phones to network equipment to any kind of screen to all the IoT devices, all of that will be combined and form one massive pool of resources and compute. And I'm not the only one who thinks like that. There's actually a term for that, fog computing, when everything comes together. And this will enable new use cases where, imagine today we are standing in a location, we are generating loads of data that we would normally have to pump up to the cloud and have it processed and sent back again. That doesn't work, right? It's just too slow. So in this new fog computing world, we can do all of that in real time from where we are right now, because we have standardized and shared access to all the compute and storage resources around us. If that's not amazing, I don't know what is. Dankeschön.